Space, the boundless, never-ending frontier. A realm where imagination meets reality and where the mysteries of the universe unfold before our very eyes. But even as we venture further into this infinite abyss, there's still so much we have yet to uncover. Today, prepare to embark on a journey beyond the stars as we unveil some of the most mind-bending, awe-inspiring, and downright crazy facts about the cosmos. Fasten your seatbelts, stargazers. You're in for a galactic ride. Venus, the scorching jewel of our solar system, at 450 degrees C. Venus is shrouded in thick clouds of carbon dioxide, with sulfuric acid raindrops, which create an intense greenhouse effect. This effect traps heat and warms the planet to scorching temperatures. The clouds are so thick that they reflect much of the sunlight, giving Venus its bright appearance from Earth. However, this reflective quality doesn't prevent the heat from the sun being trapped beneath the clouds. On the other hand, Mercury, even though it's the closest planet to the sun, doesn't have a significant atmosphere to trap heat. So, while it does get very hot during the day at night, without an atmosphere to keep it warm, the temperatures can drop drastically, averaging out its overall temperature. It's a great example of how distance from the sun isn't the only factor determining a planet's temperature. The presence and composition of an atmosphere can play a massive role in regulating or exacerbating the temperatures on a planet. This fact about Venus also serves as a reminder about the potential impacts of greenhouse gases on planetary climates, including here on Earth. Uranus, often visualized as a simple blue sphere in classroom models, has some intriguing quirks. Unlike other planets, it rotates on its side, seemingly rolling around the sun, likely due to a colossal collision long ago. This tilt gives Uranus the solar system's most drastic seasons. For about 21 Earth years, or a quarter of a Uranus year, which is 84 Earth years, one half of the planet remains in complete darkness. Though scientists expected unusual weather during its 2007 equinox, it was only in 2014 that the planet surprised them with unexpected intense storms, deepening the mystery around Uranus. Jupiter's moon. Jupiter's moon Io isn't your typical lunar body. Far from the calm demeanor of Earth's moon, Io boasts hundreds of volcanoes, making it the solar system's most volcanic moon. These volcanoes shoot sulfur plumes up to 190 miles, 300 kilometers, into Io's atmosphere. In fact, NASA notes that these eruptions release more than 900 kilograms of material every second into space around Jupiter. What causes this? It's largely due to Jupiter's powerful gravity and magnetic field. As Io orbits, its proximity to Jupiter changes, causing immense internal tensions and releasing energy that fuels its volcanic activity. However, understanding Io's inner workings remains a challenge. The distribution of heat inside Io is still a mystery, leaving scientists puzzled about the exact locations of its volcanoes. Neutron stars can spin at a rate of 600 rotations per second. Neutron stars represent a potential final stage in the evolution of massive stars. Born from the explosive demise of a star in a core-collapse supernova, they inherit a rapid rotation due to their inherent physics. Initially, neutron stars can spin as fast as 60 times per second. However, under certain conditions, this speed can skyrocket, reaching over 600 rotations per second. There is an uncountable number of stars in the known universe. We truly can't fathom the exact number of stars in the universe. Currently, we base our calculations on the estimated number of stars in our own galaxy, the Milky Way, and then multiply this figure by our best estimate of the number of galaxies in the cosmos. After crunching these numbers, even NASA can only assert that there are an unimaginable number of stars, effectively countless. An Australian National University study approximated this figure to be around 70 sextillion, or to put it another way, 70,000 million stars. Two pieces of the same type of metal touch. Cold welding is a fascinating phenomenon. When two metal surfaces come into contact in the vacuum of space, they can bond or weld together. This is because, in the absence of air or water, the atoms of the two metal pieces cannot differentiate between their own atoms and those of the other piece. As a result, they can fuse seamlessly. On Earth, the presence of air and moisture prevents this from happening naturally. This unique behavior of metals in a vacuum has significant implications for the design and construction of spacecraft, and any future endeavors involving metalwork in space environments. Mars, although seemingly dormant today, was once characterized by vast volcanic activities. Prominent among these is Olympus Mons, the largest volcano identified in our solar system. Spanning an astounding 374 miles, 602 kilometers in diameter, it's roughly equivalent in size to the state of Arizona. Standing at an elevation of 16 miles, 25 kilometers, it's 3 times taller than Earth's highest peak, Mount Everest. To put it in perspective, if we consider volume, NASA states that Olympus Mons surpasses Earth's grandest volcano, Mauna Loa, by 100-fold. The enormity of Martian volcanoes is often attributed to the planet's weaker gravity in comparison to Earth's. Furthermore, unlike Earth, where tectonic plates are in continual motion, it's believed that Mars has a relatively stationary crust. On Earth, the Hawaiian archipelago was birthed due to a mantle hotspot generating a series of volcanoes as the moving crust passed overhead. If Mars' surface remains static, this would mean a volcano could continually accrue material at the same location, thus growing even more massive over time. However, this theory remains a topic of ongoing debate among scientists. Mercury, the tiniest planet in our solar system, not counting the dwarf planet Pluto, holds the title for being the second most dense following Earth. Intriguingly, this compact planet is becoming even smaller and denser over time. For a significant span, the scientific consensus was that Earth stood alone as the sole tectonically active body within our solar system. However, this notion shifted dramatically when the Mercury's surface, space environment, geochemistry, and ranging MESSENGER spacecraft orbited Mercury. This mission provided a comprehensive high-definition mapping of the planet, revealing its surface intricacies. The data acquired in 2016 through MESSENGER brought to light the existence of cliff-like structures termed as fault scarps on Mercury. Given their modest size, researchers concluded that these formations must be relatively recent. This implies that the planet continues to contract, an astounding fact considering it's been over 4.5 billion years since the birth of our solar system. Saturn's rings. Since the invention of telescopes in the 1600s, we've been aware of the majestic rings of Saturn. However, it was only with the advancement of space exploration and the development of more sophisticated telescopes in the past half-century that we came to understand these rings more intimately. It's fascinating to note that every gas giant in our outer solar system, including Jupiter, Saturn, Uranus, and Neptune, boasts its own ring system, but there's a rich diversity among these systems. For instance, Saturn's dazzling halo, partially comprised of gleaming water ice, stands unique and isn't mirrored on any other planet. The ring systems of other gas giants predominantly consist of rocky debris and dust. Moreover, planetary rings are not an exclusive phenomenon. An example of this came in 2014 when scientists identified rings encircling the asteroid Chariklo. I hope you enjoyed the video. Please subscribe channel. See you next time.